Okay, welcome back, intro students. I know that there was an issue with the Boyle's Law notes and sample problems Ed Puzzle video. Some of you were able to access it, some of you were not. So because of that, I'm going to re-record the sample problem portion of it and maybe hopefully give you a little bit more info to help you understand it. So Boyle's Law relates pressure and volume of a gas. And it says that they are inversely related, which means as one goes up, the other goes down. So I have my volume here. It's low. My pressure is high. My volume goes up. My pressure goes down. My volume goes up. My pressure goes down. And the equation we use to express that is pressure 1 times volume 1, first set of conditions, equals pressure 2 times volume 2, the second set of conditions after something has changed. So P1 times V1 equals P2 times V2. That's the equation we're using for all of these problems. First problem. Gas has a volume of 300 ml at a pressure of 740 millimeters of mercury. Temperature doesn't change. What is the volume when pressure changes to 750 millimeters? So I specifically said volume 300 milliliters, but if I just said occupies 300 milliliters, you have to know that milliliters is a unit of volume. Millimeters of mercury is a unit of pressure, and we see it again here. So in the beginning, I have 300 ml of gas at a pressure of 740. Pressure changes to 750. What will the new volume be? So I've labeled my V1, P1, P2, V2, and I need to plug those into my equation. So that is the equation. I'm going to plug in P1, 740, times V1, 300, is equal to P2, the new pressure, 750, times, I don't know, the new volume. So you can't just stop here and copy the answer from the bottom of the page. That's not going to get you credit. You must solve the equation for the X or V2. So the way I do that is I divide, to get V by itself, I divide both sides by 750. Now V2 equals 740 times 300 divided by 750. Put it into your calculator and make sure that what you've written actually gives you 296 ml. Don't just assume you're right and copy it from the bottom of the page. So we said that they are inversely related. As one goes up, the other goes down. Well, going from 740 to 750, and that's only a little bit of an increase. So what happened to my volume? It went from 300 to 296, a little bit less volume. So a little bit more pressure, a little bit less volume. So again, we're going to go through and label our volumes and pressures. 2.45 ml is the volume one. Pressure is 1.03 atmospheres. I change the pressure to this. What will the new volume be? So our equation, still the same one, P1V1 equals P2V2. However, I cannot plug two different pressure units into that equation. So I either must convert this atmospheres to millimeters so they will match, or this millimeters to atmospheres so they will match. I chose to convert my millimeters to atmospheres. So this is a pressure conversion that you were supposed to have practiced. And I think it was homework, Gas 4 homework. Only about half of you did it. I did post some additional information. If you've watched my Here Are Your Resources video, which you were supposed to, if you're having trouble doing this, there are several places you can look for help. All right. So basically, I write down the starting value with its unit. That unit goes on the bottom. New unit goes on top. From your reference page, you can see that 1 atmosphere equals that many millimeters of mercury. 744.8 divided by 750 is 0.9800. So I'm not going to use that pressure in millimeters. My P2 is going to be entered in atmospheres. So P1, V1, P2, V2 I don't know. Solve the equation for V2. Divide both sides by 0.9800. It cancels out. Now V2 equals this. So you must show me, what V2 equals, and make sure that if you're going to write down 2.58 liters as your answer, that you plug this into your calculator and it actually gives you 2.58 liters. The third example. So it says 711.2 milliliters. It doesn't say its volume, but you have to recognize that milliliters and liters are units of volume. So it occupies this volume at this pressure. Those are my initial conditions. I change the volume, V2, what will the new pressure be? So I don't know P2. But I cannot plug ml and liters into the same equation. You must convert. So we change ml to liters based on the fact that 1 liter equals 1,000 ml, and this information can be found on your gas reference document. So I convert milliliters to liters. I'm not going to plug, I'm not going to plug this in as V1. Actually, this is V1, my bad. Sorry about that. I can't change it in the middle of this. This is actually your V1 converted to liters. Your V1 converted to liters. Your V2 is over here. Rearrange to get P2 by itself. Divide both sides by 1.44. P2 equals this. And if you put that in your calculator, you get 0.933 ATM. Okay, so I forgot to mention this at the beginning of the video, but I will mention it when I assign it, that either work these problems through with me in your notes or work these problems with me on a separate piece of paper. You are not supposed to pause this video to go and do homework problems. You're supposed to pause this video to solve the problems that are actually in this video with me.